In this video, we're going to switch gears and move on to another chapter. Now that we've talked about what probability is, we're going to start looking at probability distributions. Specifically, discrete probability distributions. And a discrete probability distribution consists of all of the possible values for a discrete random variable and the corresponding probabilities. You'll sometimes see your book use the word PDF, discrete PDF, for probability distribution function, which is the table that we use to represent our discrete probability distribution. So when you see down here we're talking about discrete probability distributions in table form, you'll often see those called discrete PDFs for probability distribution function. Before we go ahead and build one and take a look at how it works, a couple of reminders. Discrete probability distributions have to follow the same two rules that probability follows in general. First, each individual probability has to be a number between 0 and 1. I can't do worse than never happens. I can't do better than it always happens. And 2, the sum of all the probabilities in the probability distribution has to equal 1, because I will have accounted for all of my possible outcomes. Let's go ahead and do an example so we can see what a probability distribution looks like. So for this example, it says construct a probability distribution for the sum of the upward faces of two six-sided dice. So I know that if I roll two six-sided dice, the smallest number I can get is a 1 and a 1. And I know that 1 plus 1 is going to give me 2. That's the smallest sum I can have. The biggest sum happens when I roll a 6 and a 6, and 6 plus 6 is 12. So I know that my probability distribution function should have a row for all of the numbers between 2 and 12. And then I need to start calculating probability. And this is going to get messy, so I'm going to add another page below, and we're going to build a two-way table to look at the sums of the dice, because I think that that'll be easier in order to fill out probability. So let's go ahead and build a quick table for each dice roll. Okay, thank you for bearing with me here. So I'm going to write my titles here in bold so we know what we're doing. So my first roll I'll do up here. My second roll I'll do here. And my first roll could be a 1 through a 6. My second roll could be a 1 through a 6. And I want to look at the sum of the dice faces. If I go back up to that question, it said the sum. So we're just going to go through this table and add the row and column we're in. So 1 plus 1 is 2. 1 plus 2 is 3 all the way down the row. And then the same, 2 plus 1 is 3, 2 plus 2 is 4 all the way down the row. And I can see in my table, smallest sum is 2, biggest sum is 12, which is great. I can also see 3s, 4s, 5s, 6s, 7s. All of those like terms, those similar numbers, are in diagonals. That's going to help us calculate. So first thing I want to figure out, and I'm going to try and color code this to the best of my ability, is I want to know the total number of outcomes. Since this is a 6 by 6 table, there should be 36 boxes in that table. And then I'm going to start going. So my 1s, I have 1 of those. My sums of 3s, sorry, that was a 2. I have 2 sums of 3. I have 3 sums of 4. I have 4 sums of 5. 1, 2, 3, 4. 5 sums of 6. And then I should have 6 sums of 7. And then it's going to go back down from here. I should have 5 8s. And then 4 9s all the way back down our table. And that is going to help us answer our probability questions above. So let's go back to the question. It says find the probability a sum of the dice will be greater than 8. We need to fill out our table to answer that. So all of these probabilities are out of 36, and I know they follow a pattern. 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. So let's fill out that probability table. 1 out of 36, 2 out of 36, 3 out of 36, all the way down. We hit our peak at 7, and then it started to go back down again. And what I have now in this table is all of the possible outcomes for the sum of 2 dice and their corresponding probabilities. So now I can answer any probability question about rolling 2 6-sided die. Our probability example says find the probability that the sum will be greater than 8. P sum greater than 8. So I'm going to come to my table and I'm looking for the region that's greater than 8. So I know in my table that's going to correspond to numbers 9 through 12. And I know that when I have 9 or 10 or 11 or 12, I add those probabilities. So this is going to be 4 plus 3 plus 2 plus 1. And that's going to be 7, 8, 9, 10 out of 36. So probability distribution functions, or tables, for a discrete probability distribution, all we do is identify all of the possible outcomes and then calculate the individual probabilities for them. Once we've done that, we can then use those probability distribution functions to answer probability questions. When I see you in the next video, we're going to talk about means and standard deviations of these probability distributions. And then we're going to talk about a very specific discrete probability distribution. As usual, if you have any questions, feel free to send me an email or drop by the Thursday office hours. Otherwise, I'll see you in our next video.